Here we have the mean shelf life of a slice is 13.4 weeks and the standard deviation is 1.8 weeks. Now, in part A of this, what we need to do is we're asked, would a shelf life of 20 weeks be unusual, and what's the reason why? So first case here, the best way to go about this is to calculate what the z-score is going to be of this. So z-scores are found by taking score minus the mean over the standard deviation. So in this case here, what it's going to be, the z-score is going to be equal to 20 minus 13.4 over 1.8. And in this case here, that's going to give a result of 3.67. Now, as for providing an answer here, what the answer would be is 20 weeks would be unusual. And the reason that would be unusual is having a z-score above 3 is highly unlikely because 99.7% of the scores are going to be between a z-score of -3 and +3. So if you've got one which is less than -3 or greater than +3, it's highly unlikely because that's only 0.3% of scores which are likely to occur there. And given this one is not just a little bit over, but a significant amount over, the chance of that occurring, while it could occur, is incredibly unlikely. So therefore, because of its z-score being greater than 3, it is unlikely. Okay, for part B here, we're asked to find the z-score for a shelf life of 15.5 weeks. So as we go about this here, a z-score for this is going to be 15.5 minus 13.4. That's going to be divided by 1.8. And so calculating this, this then gives us an answer of 1.17. For part C, we're asked what percentage of shelf lives would be expected to be between 13.4 and 15.5. So in this case here, we're going to have to use the z-scores, which we have already for both of these. Now, in the case of 13.4, this is the mean. So therefore, its z-score is going to be 0. One other thing we can find out then is when we're finding the percentage of scores underneath this in the PDF, in this case here, this is going to be equal to 0.5. So we already know that aspect already. So P here of Z less than 0 is equal to 0.5. Because it's the mean, it's halfway, which is already calculated there. Now, the other one we have to do is 15.5. We have the z-score from the previous question, and this is going to be 1.17. What we do need to do is we do need to go and look this up on a table. So with a z-score of 1.17, we're going to use the left column first to find 1.1, which is at that point there. We're going to go across until it comes across to the 0.7 here. So where they intersect is at this point here. So we can see that value is 0.8790. So P of Z of less than 1.17 is equal to 0.8790. Now, what we're asked to find is the percentage between these 2 points. Now, as we do that here, that means we've got to subtract them from one another. So we're going to have 0.879 minus 0.5. This gives us 0.379. But because we're asked for a percentage, we've just got to convert this from a decimal into a percentage. So that means there are 37.9% of the shelf lives will be expected to be between 13.4 and 15.5.